As we continue on with undetermined coefficients, remember from last time we're working on, the problem looks like this one, where we have a second order differential equation with constant coefficients a, b, and c, and the right hand side has some forcing function here. So we started our study of second order equations with the homogeneous case where f of t equals 0. Now we're looking at the case where we have other functions here. Now for undetermined coefficients, like we talked about last time, this forcing function is going to be either a polynomial or an exponential or sine or cosine or some combination of those. For more general functions, we'll use variation of parameters, which we'll talk about next time. So continuing on with this, looking at these examples with different types of functions here. Just to remind you, the setup of this is that our solution, y of t, is the sum or the superposition of two solutions. The homogeneous solution, which we've talked about before, and then this particular solution, which is the new part, the part that we're working with in this example. So the homogeneous solution, this is the solution to the same example, ay double prime plus by prime plus cy equals 0 though. And then the particular solution is the one that we guess, and then we check to find the coefficients. Let me say here, we guess the particular solution, and then we plug it into the differential equation with f to find the coefficients that belong to our guess. So in our guess, we have some coefficients a, b, c, etc. These are the undetermined coefficients, and we determine them by taking that particular solution and plugging it in to this side of the equation and just equating and doing some algebra. So the process is pretty straightforward, but the key is that you have to start by selecting the appropriate particular solution, or at least the correct form of it in order for this to work. So we talked about the theory behind this last time, but the idea again is that once you know the solution to the homogeneous one, changing it to a non-homogeneous case, as long as you find any particular solution, the full solution is the sum of those two by superposition. So our particular solution, again, we guess and find the coefficients. So for example, we started this one in class last time, but I'll work it out for you here. Starting from the beginning, we have our f of t is going to be sine of t. We talked about last time how maybe you might say, well, let me guess then, as we did with the polynomial examples before, let me guess that the particular solution has the same form as f of t. And so if you did this, then you would need to find y prime and y double prime to substitute in to these three places in the differential equation. So y p prime would be a cosine of t, and yp double prime would be negative a sine of t. So when you substitute these in, you have y double prime, so negative a sine of t, plus 3y prime, so plus 3 times a cosine of t, plus 2y, so plus 2a sine of t, equals sine of t. Now what happens if you try to solve for a? Well, if you start collecting things together, you have negative a sine of t. Well, I'll do it this way. You have negative a sine of t plus 2a sine of t. So when you combine those, you just have a sine of t. And then there's only one cosine term, so that remains unchanged, equals sine of t. So the coefficient of sine of t on this side is a 1, and the coefficient of cosine over here would be a 0, right? So the idea now is that the coefficients of sine over here have to be the same as the coefficients of sine over here, and the coefficients of cosine have to be the same as the coefficients of cosine over here, which leads to this conclusion that a equals 1 and 3a equals 0. Now what's the problem here? The problem is that a has to equal two different things. In other words, we've got two different answers for a. And we've seen this before. We saw this in one of the early examples with the polynomials last time, where we hadn't accounted for enough possibilities, and so we got duplicate answers or multiple answers that were incompatible. So this is impossible. This breaks down, right? This is a failure of the process, which means that the yp that we selected wasn't general enough. And if you notice, the reason it wasn't general enough is because it didn't account for the possibility that a cosine is going to show up in the problem. So we mentioned last time what we would do to solve this, and the idea is that even though there's only a sine here, our y of p needs to contain a possibility for there to be a sine and also a cosine. So let's try that instead and see what happens. So let me copy the question down again, just so we have it to refer to. And then let's pick a new y of p. So my yp is going to be a combination of sine and cosine. So I need a coefficient for the sine term, I need a coefficient for the cosine term. By the way, at this point I'll mention, if there were something like a 4 here, I would have 4s inside each of these. So again, the form of this dictates the form of these. But if there's either a sine or a cosine here, or a combination of the two, then this will be the form for yp. So yp, this standard form of the combination of sine and cosine, works whenever you have sine or cosine in your f of t, or both. And we'll summarize more of that later on. But for now, we're going to do the same process where we're going to substitute into the differential equation. So we're going to find y prime, which would be a cosine of t minus b sine of t, and then y double prime, which would be negative a sine of t minus b cosine of t. Now substituting in, there's a lot of terms here and it gets a little tedious to collect all of these, but stick with me for a second. Here y double prime goes here, plus 3 times y prime, plus 2y, equals sine of t. So again, all the coefficients of sine on the left side have to combine to 1, and all the coefficients of cosine have to combine to 0, because there's no cosine on the right side. So just to make this a little bit easier to follow and to have less writing, I'm going to go ahead and just look at the sine terms over here. So I'm going to kind of pick these out. I've got one here, one here. Now notice there's going to be a 3 that goes there, and then 1 here. So those are my terms with sine in them. And I'm just going to add together those coefficients and equal them to 1. Again, because the coefficient of sine on the right is 1. So here I'm going to have negative a minus 3b. Notice the 3 and the minus. Gotta make sure you distribute carefully here. And then plus 2a. So all of that together equals 1. And then I'll do the same thing with cosine. So now picking out the cosine terms, that's this one, and this one. Notice again this 2 is going to distribute here. And those all have to combine to equal 0 because there's no cosine on the right. So negative b plus 3a plus 2b equals 0. Now of course both of these simplify, and again it's a pretty simple system of equations to solve. We have here a minus 3b equals 1, and we have here b, or I'll do it this way, 3a plus b equals 0. Now to solve this, you can do this system of equations. You can either do substitution. For instance, you could take this and move it over here and say a equals 3b plus 1, and then substitute that here. Then you would have 9b plus 3 plus b. Or you could do elimination, where you could multiply the second equation by 3 and then add the 2 to cancel the b's. However you do it, what you should end up with is that a equals 1/10 and b equals -3/10. And again, I'll leave that to you to finish, but either by substitution or by elimination, you can finish that up pretty quickly. So what this means is that our particular solution for this one, remember the form was a sine of t plus b cosine of t. So if a is 1/10 and b is 3/10 or -3/10, the particular solution looks like this. And of course we didn't do the homogeneous solution for this one, but if you did that, then you would add that on to the full solution. So the full solution would be the combination of the homogeneous one and the particular one. Really quickly, if you just notice, if we have this, we have y double prime plus 3y prime plus 2y. If we solve the homogeneous case equal to 0, then we'd have r squared plus 3r plus 2 equals 0, which factors as r plus 2 and r plus 1. So r is -2, -1, which means our homogeneous solution would be c1 e to the -2t and c2 e to the -1t. So the full solution would be the combination of y sub h and y sub p. So depending on the problem, you might just be asked to find a particular solution. You might be asked to find the full solution, y sub h plus y sub p. For most of these examples that we'll do in this unit, I'm going to focus on finding y sub p, just because that's the new part. Y sub h is more familiar, and so we won't necessarily take the time to do that each time. But just know that the full solution to one of these problems is the combination of the two.